So, welcome to the Day of Friday. My name is Michael Olschimke. I'm the CEO of Scalefree. We run this session here essentially every Friday, 11 o'clock Central European Standard Time, to allow you, the audience, to ask questions about data vault. All kinds of data-driven questions are allowed, anything cloud relevant, and so on. Yeah, you can use the chat here. You can use the Q&A for live questions. You can just raise your hand if you want to raise your voice. All good. You can also use a form, which I show you afterwards, after today's session, where you can upload your questions, essentially upload some pictures if you want, to allow us prepare a slide maybe. And if you receive multiple questions, I would cherry pick from those questions essentially. So no legal obligation to answer all the questions, right? We just do the best we can. And it's time up. So it's typically good for a good YouTube video, 10, 15 minutes roughly for these answers. If there would be no questions at all, I will talk about the cluster here. My little side project in the basement. This is my private basement here. But yeah, so but we typically have enough questions. So once in a while over the summer, actually, I do talk about the cluster and show you some stuff around. Now, let me just check. There's something in the Q&A for maybe a live question. Okay. So here's one quick question. Let me just show it to you. One small question. Can we use reference tables in links? If not, why not? I assume, Jinxin, that you mean reference codes in links. And that's if that's the case, we're looking at a dependent child link or degenerated link where you can have codes, reference codes in those link structures or additional elements in the link structures, typically used for like invoice line items, where you get the line item number added to the link structure, right? To capture the granularity of your source data. But in some cases, this granularity might also be identified by some code. Let's say you receive data and in the source system, you get one row per country, that kind of stuff. Like one relationship per country somehow. In this case, you could have a scenario where you have a reference code in a link structure. Follows the dependent child link discussion that we do in the training. It's just not a number, it's a code essentially. Whatever the code is in your case, right? So it will be valid, absolutely. Yep. So that's which means you refer to a reference table from the link. That's true. All right, good one, good quick one. Let me show you the slide I prepared for a question that we received. This one is about hash keys in the business vault. And what they do is they apparently calculate hash keys for links in business vault, and that becomes sometimes expensive, okay? Because they have to join or get the business keys essentially for the link. So the link has, let's say, 2, 3 or 4 or 5 hub references, and they need to calculate those hash keys for the hub references and the link itself. And I think the biggest problem here is the hash key of the primary key of the link. And for that, they need to get the business keys essentially. Now, and I forgot the light here. The thing is this, and then they also have the additional problem that if there's a satellite attached to the link, that essentially adds up as well. So now the thing is this. And so is it still a no-go to generate the link hash key from the hub? So yeah, so the thing is this, first of all, I wouldn't calculate the hash key from, the hash key for the primary key of the link from the hash keys of the referenced hubs. I would always use the business keys, first of all, to stick to the pattern. Especially in a raw data vault, it's actually cheaper to use the business keys for calculating the hash keys, because to compute a hash key based on hash keys, you have to calculate the hash keys that you want to compute a hash key from first, right? So there's a multiple layer approach, and that takes more time. So in a raw data vault, if you have, let's say, a link with 4 hub references, you have the business keys for those hub references in your staging table. You just concatenate them, one hash computation, and you're done. If you want to calculate the hash key from the hash keys, you have to calculate 4 hash keys first, and then calculate the hash key from the hash keys. So it's 5 computations versus 1. So in the raw data vault, it's relatively clear, or it should be clear. In the business vault, it depends. But the thing is this. I typically don't calculate hash keys in a business vault. That's why I find this question, yeah, it's not weird. It's just, I think there's an underlying problem here. The thing is this. What I would do is this. I would always stick to some granularity that you already have. when doing something in the business vault. So let's say you have a link where customers walk into stores, purchase products, and you want to calculate or derive some, or there's some satellite attached to it where you have these, let's say, transaction prices that you want to correct or recompute from your foreign currency into your leading currency, something. So you have already a satellite that provides you the granularity for your results. Stick to that, because then you can use the same primary key, same hash key, same load date, and derive the new satellite, the compute satellite in the business vault based on the same primary key. And that allows you, that concept alone allows you to easily load the business vault incrementally, even though it might be a materialized table. Let's say you have a Python script, external Python script that calculates these compute deltas essentially. So just stick to the primary key always of hubs, links, satellites. That's what I would do. And then the problem becomes, I would say, much less. I mean, that concept is the basis for virtualized business vault entities anyway. You can't afford calculating hash keys in a virtualized manner, right? So, and we argue that you should have like 60 to 80% of your business vault entities should be virtual. So there's no room for calculating hash keys. And if you have to, let's say, there's a grain shift involved here. So there's some, here's some extra comment here. If the business vault requires a grain change compared to the raw data vault, you do need to recalculate the hash keys. That's correct. So if you do a grain shift, there's two types of entities coming to play. It's either the bridge table, which we use to prepare the granularity of the target, of the fact entities, or a computed aggregate link. That's typically used for pre-processing the grain shift, so I can reuse it for multiple bridge tables on cascading grain shifts, that kind of stuff. So, to have KPI calculations, I want to reuse essentially for multiple targets. In this case, you have to calculate the hash key of the bridge table or of the computed aggregate link. That's a typical scenario, and then I agree. But still, the thing is, the effort for calculating the hash key in this case is based on the business keys. The extra effort of retrieving the business keys should be relatively straightforward and simple. It's just inner joins into the hubs. So I would actually do that just to stick to the standard pattern, and because it's really only for a few entities. That's my argument. The thing is, for the bridge table, you could. Yeah, for the bridge table, in the book, we have a primary key, which is a hash value. And that's it could be used for a fact identifier. But it's arguable if you actually need a fact identifier. And there's actually a lot of people who would say, what for? Because you're not attached anything to the fact entities, right? So you could argue that the bridge doesn't need to have a unique identifier, or maybe just a sequence, for example. So that's also a thing. So if you really have a problem with joining those hubs, you could just say, for the bridge table at least, there is no unique identifier for the fact, because there's no need for that. So you only have the hub references and maybe an alternate key on those hub references and maybe some transaction ID or something, or some dependent child element. That's sufficient for the bridge table. For the compute aggregate link, there's typically a satellite involved, which is attached to the link table. So you need a unique hash value, and that should be like a unique primary key, and that should be a hash key. For the bridge table, in some cases, you might not want to attach something to the fact entities, but you might want to attach something to the bridge table, or on that granularity, some compute satellite, for example. In this case, like when you extend a bridge table later on, super large fact table, and now you want to add some additional computations, and you can't afford modifying the underlying pages, the table pages in the database. In this case, you might also want to attach something to the bridge table. That's why the primary key of the bridge table comes into play again. But still, I would stick to the pattern. Just because it's, I mean, there's some means and some options these days where you can generate some parts of the business vault as well, and that's why I would stick to the pattern, because then essentially the way how you calculate hash key is always the same. That's what I would stick to. On the other hand, as a counter argument, right? So make it a bit more complicated here. On the opposite, the thing is this: as long as the hash key is unique, I mean, so here's the thing: in the business world, you have more freedom of deviating from the standards. That's number one, because if you mess it up, you can reload the business vault without reloading the whole raw data vault or the whole data warehouse, essentially. That's the basic idea. So you have some more freedom. And from a pure technical perspective, as long as the hash key is unique, it's fine. So I wonder if I regret something, but based on that concept, you could deviate from it, but I wouldn't do it. It's just too cheap to get the business keys. That's my problem. What I have. I agree. It's more complicated code, but that's easy to generate. So that's why I would stick to the business key pattern and not using hash keys or derive hash keys from hash keys. That's it. That's the main argument, the automation argument, which comes into play more and more in the business world as well. And that's why I would stick to the business keys, to the standard pattern. All right. So that's the answer for the slide here. There's more questions coming in. Good. Jixin, another question. My colleagues mentioned that they have learned snapshot control table in the training, but I can't find this concept in the book. I guess snapshot control tables are the pit and bridge tables, or could it mean anything else in Data Vault 2.0? Yeah, so the thing is this: the pit tables and bridge tables are driven by snapshots. But now the problem is, for example, for the pit table, you can remove old snapshots after some time. And typically customers do that. They want to get rid of old snapshots because the pit table is a large table by itself. It's a large index. And you typically most customers don't want to spend so much storage for keeping all the snapshots of, let's say, the last 10 years. So what they do is instead, they, let's say they keep the last 30 snapshots every day. And then after 30 days, they only keep, let's say, a monthly snapshot for the next 6 months. And after 6 months, they only keep a yearly snapshot, that kind of stuff. So it's what we call a logarithmic snapshot table. Or they just keep the last 6 months of snapshots on a daily basis. And after that, they just get rid of everything else. So those options they play with, they manage the snapshots, especially in the pit table. And for that, we have a control table. We actually have two control tables in our system typically. We have a control load table where we keep track of the load date timestamps, like the batches we receive from each source system. Remember, a batch is identified by a load date timestamp. And so per source system, or per connection actually, per connection and per load date, we have one record in this table. And then we have essentially timestamps that indicate where this batch is. Is it already in a data lake? Is it already in, let's say, maybe a relation staging area? Is it already in the raw data vault? Is it processed by the business vault? And so on. How far did you push the batch downstream? And then, because the information delivery is decoupled from the data warehousing phase, we have another control table where we keep track of the snapshots that we want to keep in the pit tables. And yeah, that's the idea. Let me just, before I talk around something here. Okay, so that's our control schema where we have these control tables. And for example, we have this control load table or control LDTS table sometimes. That's where we keep track of essentially all the source systems. So we have a source identifier, like the type of source, and then the connection. And then, because we might have multiple connections into the same source system with different user rights and whatever. And then you have, we have the load data timestamp that identifies those two columns here, identify the batch of data coming into the system. And then we indicate where it is. Is it already staged? Did the stage end it? The enterprise data was layer with the raw data vault, the business vault, did it start? And inside this layer, we have the raw data vault start and end and the business vault start and end, but that's virtualized. So we typically don't update anything here. There's no process running for that. All right, so that's the control load table. And the one you refer to is the control snapshot table. The snapshot is on a regular basis, once a day, for example, in our case at 7 o'clock UTC. We're sitting here in Germany, so it's 8 o'clock in the morning, at least typically. And then we indicate, so there might be some name. So we add some, we might overwrite the name and say, well, this is, I don't know, the birthday of your wife, Christmas, I don't know, New Year's Eve, that kind of stuff. Or just snapshot of a given day, right? Super boring. And then we indicate what kind of snapshot is it. Is it a real-time snapshot? We don't use it internally at the moment. Is it an hourly snapshot? Yeah, because it's at the 7th hour, so UTC. So it's an hourly snapshot all the time. Is it the daily snapshot? Yes. Weekly snapshot only the Monday or Sunday or something, but it's not ordered. Let me just order this. So there should be once in a while a weekly, right? So that should be the first of the month is then the monthly snapshot and so on. That's the cool thing is this becomes an input for a dimension, and you can use that in your dashboard to filter down for, let's say, report on a monthly basis or daily basis. You just filter for those flags essentially. That's the idea, and we use it also. We discuss it in detail in the information delivery class, where we also use the replacement snapshot timestamp. When you get rid of one snapshot from the pit table, you still have the facts, right? So there was a transaction or some IoT message or whatever that refers to your dimension member on a given snapshot date based on your pit table. But that snapshot is gone, but only from the dimension, from the pit table, not from the bridge table. So what we do, and we use this replacement snapshot to indicate what is the best dimension record to replace this snapshot. So if you have a logarithmic pit table and you're removing everything after 3 months, except the beginning and end of the month. So the best one for, let's say, we have January now, for, let's say, the 15th of, I don't know, October 2022, will be then the end of October 22. So that's the replacement snapshot, and your dimension model still works. All the joints will work and so on. So in your fact entity, you replace the snapshot date of the fact for the dimension reference by this snapshot date. That's what you join against essentially. That's the basic idea. All right. So that's what they most probably refer to. That's what I would assume. Regarding the hash generation, one thing that is not clear. Sorry, here's the question. Regarding the hash generation, one thing that is not clear for me yet is, for example, if I have an expiration link, yeah, like a business link, expiration link, should we also prevent generating the hash keys, but how? Or is this an exception? It might not change granularity. So you're right. So expiration is also something where you have different, where you often either create a shortcut in your data model, having different hub references which are not coming from the source. Let's say a shortcut between multiple systems or something. I agree. Then you also have to calculate the hash key. You typically don't virtualize a expiration link, at least for this purpose, because it's you want to create a shortcut for performance reasons, and that's why you materialize it. Again, I don't see a problem joining the business keys and then hashing it. The hash key computation will take some time, but this table should be materialized anyway to improve the join performance. If it's a, let's say, there's also a business link, also known as a deep mining link or something. In this case, the expiration link or the business link is based on some data mining patterns, but those are typically coming from external scripts like Python scripts or RabbitMiner jobs. And in this case, you also you often have a basis, a granularity. Let's say you have actual transactions, retail transactions, and you want to calculate product recommendations. Do you have a? Yeah, you might not have a hash key, but then again, you can calculate this in the external tool, and because the data mining is typically external, and you write the results into a table. So the hash key computation by itself, the performance drawback is not a problem because these tables are materialized typically, and the inner joins shouldn't be a big problem. That's at least from my experience, is not a big problem. But yeah, so yeah, it doesn't change the granularity, but it changes the hub references. That's the problem of the expiration link typically. I agree. Eric, despite the name, the expiration link is still the regular business vault link naming convention. It may not be for data mining expiration reasons. Yeah, so the expiration link is also known as the business vault link, or business link is also known as the deep mining link. It's just a standard link in the business vault, where the results are not coming from a source system directly, but from your computations. Could be super simple. You just filter out some records which are invalid. This customer can't purchase this product because there's a limit. I don't know. And so you filter out some invalid records. Super simple. Or you just pre-join some shortcuts between hubs from two different systems. There will be no link between that you can load from a certain source system because these hubs are completely in different systems, right? So you need to compute this based on some intermediate links in between in the hubs. That's a typical example we do in the bootcamp class where I'm creating or where we discuss how we create shortcuts in your model for these lead journeys, essentially. And then you could, and then another often case is to create artificial links in the business world based on some data mining, fraud detection, product recommendations, lead generation practices, and so on. So, or yeah, that's the idea. So that's the other reason, but it's just a standard link in that sense. So there's not the structure doesn't change. It's just calculated somehow based on business logic, based on simple filter logic, based on some data mining algorithm. And if the link is materialized or virtualized, that's really a question typically for the business world link. It's typically a question of the algorithm. If it's just pure SQL, just virtualize it. If it's more complex data mining, then you have to go external anyway. And if your purpose is to improve the performance, if you want to use this business link for performance reasons, then you have to materialize it anyway as well, typically. So like the expiration link, where you create a shortcut in your model, you do this often for creating a higher performance solution, essentially, to reduce the number of joins for a specific query, essentially. That's the idea. All right. Yeah, good questions, guys. Love it. Yeah, if you want to post a question like this, use this form here, https://sfr.ee/dvfriday. That's a form where you can type in your questions, upload pictures if you want, maybe a photograph of your whiteboard or team picture, whatever works. Everything I upload there might be published here on the channel, right? And then we also have other webinars at the moment for Warescape and DBT, where our consultants, I'm not a tool expert, to be honest, and our experts from the consulting base who really know Data Vault, Data Vault for sure as well, but also Warescape and DBT in and out, they essentially do the webinars here. And that's behind, or there's a link essentially, scalefree.to/webinars. That's where you find essentially the upcoming webinars. They do this once a month. We do the Data Vault Friday here once a week, but both is worthwhile to watch. All right, guys. Thanks for joining. Yeah, enjoy your weekend, guys. And hope to see you next Friday here, same time, same room. Thank you, guys. Bye-bye.
Thanks for joining today. If you'd like to discuss this further, give us a call on the number below here, and we're happy to discuss this with you. See you next time. Have a nice weekend. Bye-bye.